Students, in today's lesson, we will do questions on physical quantities and units, which is chapter 1 of our AS Physics syllabus. Students, from examination point of view, this chapter is perhaps the most important chapter because in paper 1, about 5 questions come from this chapter. Students, in this workbook, first 6 questions are on SI base units, and homogeneity of a physical equation. So let's do the first question first. Question number 1.1. Which quantity is a physical quantity? Students, we know that a physical quantity consists of a magnitude and a unit. Now, what does it mean? It means that a quantity can only be regarded as a physical quantity if it has a magnitude and a unit, right? Now, let's look at the options. Option A is atomic number. Students, atomic number has no unit. Why? Because it is a pure number. So, atomic number cannot be regarded as a physical quantity. Option B is efficiency. Students, efficiency is given by this expression, power output over power input, right? Now, from the expression for efficiency, it follows that efficiency also has no unit. Why? Because see, power output and power input, they have the same unit, so they cancel each other out, leaving efficiency with no unit. So efficiency is also not a physical quantity, right? Now, next option, option C is number density of charge carriers. Students, we know that number density of charge carriers is given by this expression, N over V, where N is the number of charge carriers and V is the volume. From the expression for number density of charge carriers, it follows that the unit of number density of charge carriers is per cubic meter, right? So, number density of charge carrier may be regarded as a physical quantity. Last option, option D is strain. Student, strain is given by the expression delta L over L, where delta L is the change in length, L is length. They have the same unit, so their units cancel each other out, leaving strain with no unit. So students, strain may also not be regarded as a physical quantity. So correct option is option C, right? Let's do the next question. Question number 1.2 on page number 5. Students, question number 1.2 says, what could not be a measurement of a physical quantity? Students, we know that a measurement of a physical quantity consists of a magnitude and a unit, right? Now, option A is 10 Kelvin. Now, 10 is the magnitude and Kelvin is the unit. So 10 Kelvin is a measurement of a physical quantity, right? Option B, 11 joule per Newton per meter. Here, students, 11 is the magnitude, but we don't know whether joule per Newton per meter may be regarded as a unit or not because we don't know what this combination of units is equal to. So let's determine what this combination of units simplifies to. Students, joule is the unit of work, right? And work is given by the expression force times displacement. Now, as a unit of work is joule, as a unit of force is Newton, as a unit of displacement is meter. So joule is equal to Newton meter, which means that joule per Newton per meter, joule per Newton per meter may be written as Newton meter per Newton per meter, right? Now look students, Newton meter per Newton per meter, they all cancel each other out, which means that joule per Newton per meter is equal to no unit. So students, 11 joule per Newton per meter is not a measurement of a physical quantity. So the correct option is option B, right? Now look students, we have determined the correct option, so we don't need to check the remaining options. Why? To save time. Students, remember that in paper 1, the real challenge is not to get all the questions right, but the real challenge is to get maximum questions right within the time limit. So students, try to save your time wherever you can so that you can get maximum questions right in the designated time. So let's move on to the next question, question number 2 now. Question number 2. What is the unit of resistance when expressed in SI base units? Students, in this question, we have to determine SI base units of resistance. We know that to determine SI base units of any physical quantity, all we need is the expression for that physical quantity. And we know that resistance is given by the expression potential difference over current. Students, potential difference has SI unit volt and current has SI unit ampere. Ampere is an SI base unit, but volt is not an SI base unit. What does it mean? It means that if we want to determine SI base units of resistance, we will have to replace potential difference by its expression in the expression for resistance. So let's do that. Students, potential difference is given by the expression energy transformed per unit charge, right? So resistance may also be given by this expression. Let me first simplify this expression. W over Qi. Students, in this expression, W is energy, SI unit of which is joule, Q is charge, SI unit of which is coulomb, and I is current, SI unit of which is ampere. See students here, joule is not an SI base unit, coulomb is also not an SI base unit. So we will have to replace W and Q by their expressions now. Let's replace energy W by its expression. Students, you can use any expression for energy here. I'm going to use the expression for change in gravitational potential energy, mgh. And for charge Q, I'm going to use this expression I times T, where I is current and T is time, right? So this is the new expression for resistance. Now students, we have obtained an expression for resistance. In terms of physical quantities, we know the SI base units of. We can use this expression for resistance to determine what? To determine the SI base units of resistance. Let's do that. Students, SI base unit of mass is kilogram. SI base units of G, acceleration of free fall, are meter per second squared. SI base unit of height h is meter. SI base unit of current is ampere. SI base unit of time t is second. SI base unit of this current is also ampere. Now, all we have to do is simplify this expression. Simplifying this expression gives kilogram meter squared s to the minus 3, a to the minus 2. So these are the SI base units of resistance. So students, see, it is option D which is correct. Kilogram meter squared per second cube per ampere squared, right? Let's do the next question now. Question number 3. Which two units are not equivalent to each other? Newton meter and kilogram meter squared per second squared, Newton second and kilogram meter per second, joule per second and kilogram meter squared per second cube, Pascal and kilogram meter per second squared. Students, first of all, note that these four units are all SI base units and these four units are not. So to check whether these units, they are equivalent to each other or not, let's determine SI base units equivalent to these units first, starting with Newton meter. Students, see, Newton is the SI unit of force, right? And force is given by the expression ma, where m is mass and a is acceleration. Mass has SI base unit kilogram, a has SI base units meter per second squared. So see students, kilogram meter per second squared are the SI base units equivalent to Newton, which means that SI base units equivalent to Newton meter are kilogram meter per second squared times meter, which is equal to kilogram meter squared per second squared. Now see students, these SI base units, kilogram meter squared per second squared, are the same as these SI base units. So Newton meter and kilogram meter squared per second squared, they are equivalent to each other. Now students, use the same method to check whether these units, Newton second and kilogram meter per second, they are equivalent to each other or not. Students, I have done all 500 questions in the workbook and I know that these units are also equivalent to each other. And similarly, next two units, joule per second and kilogram meter squared per second cube, they are also equivalent to each other. But these two units, Pascal and kilogram meter per second squared, they are not equivalent to each other. Let me show you how. See students, Pascal is the SI unit of pressure. Pascal is the SI unit of pressure and pressure is given by the expression F over A, where F is force and A is area. Students, force is given by the expression ma, where m is mass, A is acceleration, capital A is area, m is mass, its SI base unit is kilogram, A is acceleration, its SI base units are meter per second squared, capital A is area, its SI base units are meter squared. Students, this whole expression simplifies to kilogram per meter per second squared. So these are the SI base units equivalent to Pascal. And note that they are not the same as these SI base units. These SI base units are kilogram meter per second squared, and these SI base units are kilogram per meter per second squared. So students, Pascal is not equivalent to kilogram meter per second squared. D is the correct option. Students, next question, question number 4, is similar to question number 3 in the sense that it also requires the use of the same approach as we used in the previous question, question number 3. So I'm leaving this question as homework for you. Let's do next question, question number 5. Students, this question is about homogeneity of a physical equation. Homogeneity of a physical equation. In this question, students, we will use property of homogeneity of a physical equation to determine the value of a constant. That constant is actually one of the powers in the equation. So let's read the question first. The speed v of a liquid leaving a tube depends on the change in pressure delta P and density rho of the liquid. The speed is given by the equation v equals k times delta P over rho whole power n, where k is a constant that has no units. What is the value of n? Now see students, in this question we have to determine the value of n. What is n? See students, n is actually the power of the expression delta P over rho in the given equation. Students, remember that in all such questions where we have to determine the value of a power in the given equation, we almost always use the property of homogeneity of the physical equation. We use this property to write an equation from the given equation that only contains SI base units. That only contains SI base units. And then students, we use another mathematical property to determine the value of the power in the given equation. Let me show you how that's done. See students, this is our given equation in this question. From this equation, using the property of homogeneity of physical equation, we can write SI base units of V, where V is the left hand side of the given equation, are equal to SI base units of K times delta P over rho whole power n, where K times delta P over rho whole power n is the right hand side of the given equation. Students, SI base units of V are meter per second, and SI base units of K times delta P over rho whole power n are meter to the 2n and S to the minus 2n. Students, actually I am skipping some steps here to save time. Students, if you find the SI base units of this expression, you will end up getting these SI base units. Now students, note that this equation only contains SI base units, meter and second, and they are both SI base units. Students, now we can use the mathematical property that I was talking about earlier to determine the value of power n. Students, according to this mathematical property, if there is an equation that only contains SI base units, for example, this equation only contains meter and second, then for any specific base unit, for example, meter, we can equate the powers on both sides of the equation. So for meter, students, we can write power of meter on the left hand side, which is 1, is equal to power of meter on the right hand side, which is 2n. Now students, we can easily determine the value of n from this equation as 1 by 2. Now students, if you want to verify your results, you can equate powers of the other SI base unit in the equation. For example, students, for second, which is the other SI base unit in the equation, we can write power of second on the left hand side, which is minus 1, is equal to power of second on the right hand side, which is minus 2n. Students, this equation will also give you the same value for n, 1 by 2. So n, which is power of the expression delta P over rho in the given equation, is equal to 1 by 2, right? Now students, next question, question number 6, also requires the use of the same approach as we used in the previous question, question number 5. So I'm leaving this question as homework for you. Let's move on to the next question, question number 7 now.